In this video, we'll be looking at probabilities with combinations and permutations. So for our first example, 5 cards are drawn from a deck. What is the probability that 2 are aces? If we're choosing a group of items from a larger group of items and order does not matter, that's when we use combinations. So if you remember, combinations are written as C in R, where N is the number of things we have to choose from, and R is the number we are going to choose. Now it's very important that N and R refer to the same sort of thing. All right, so we want 2 that are aces. So for our combination, we are looking at aces, and we want to think of how many do we have and how many do we want. So we have 4 aces, and we want 2 of them. A common mistake is to put 52 and 2, because we have 52 cards and we want 2 of them to be aces, but remember, N and R need to refer to the exact same thing. So if we have 4 aces, we can choose 2 aces. So N and R need to agree. Now, that doesn't actually complete our 5-card hand. So what we can assume from this problem, since we're told that 2 are aces, is that 3 of the cards are not aces. So we have a combination for our aces. We're also going to need a combination for the non-aces. So again, first number is how many do we have? So non-aces, if we have 4 aces, 52 cards total, that gives us 48 non-aces. And how many do we want? Well, we have 2 cards drawn already, so we need 3 more. So we have a combination for our aces and a combination for our non-aces. Now, this number is 48 because that refers to the number of cards that are not aces, not to the number of cards that are remaining after we've drawn these 2. So since we want 2 aces and 3 non-aces, we'll multiply these together. And then we'll divide by the total number of ways in which 5 cards can be drawn from 52. So in this case, we will use 52 because we have 52 total cards and we want 5 total cards. So the N and the R agree here. And so if we calculate this out, what we end up with is a decimal that's approximately 0.0399. Let's look at another example. If 5 people are randomly arranged in a line, what is the probability that they will be standing in ascending order of age? Now in this one, when we see the word order, we can assume that we are talking about a permutation, things where the order matters. Okay? So what we need to do is first figure out how many different ways they can be standing in ascending order of age, and then how many ways can 5 people be arranged in a line. Well, the number of ways in which people can be arranged in ascending order is 1. There's really only one way, and that's for the youngest person to be first, and then the oldest person to be last, and in between, they're in ascending order of age. So there's only one way to do that. Our denominator will be how many ways can we rearrange 5 people in a line. And so to do that, we'll use a permutation. There are 5 people, and we want to arrange all 5 of them. And so the probability that these 5 people will be standing in ascending order of age is 1 over permutation 5. And what that gives us is approximately 0.008